So hello students, welcome to the complex integration session. So in last class I discussed Cauchy's integral formula and Cauchy's integral theorem and its consequences. So today I would like to discuss one more important concept, that is Cauchy's integral formula for the function f of z. Here's, you see this theorem. Okay, this theorem states that if f of z is analytic, if f of z is an analytic function within and on a closed contour, C is the closed contour and z is equal to a is an interior point of C. So a is an interior point of C. So then integration of f of z by z minus a. What is that? A is an interior point of C. Okay. So then integration of f of z by z minus a with respect to z is equal to, that is equal to 2 pi I into f of a, or f of a can be written as, so just rearrange this one. So then we get f of a is equal to 1 by 2 pi I into integration of f of z by z minus a into dz. Yes, to prove this Cauchy's integral formula, okay, it is one of the important result. To prove this Cauchy's integral formula, first you consider the function f of z by z minus a. So you see here, f of z by z minus a is a function. It is analytic entirely within C except at z is equal to a. So because if you take z is a, so then the denominator becomes 0. So in that point, that function f of z is not an analytic function. So except at z is equal to a, in all the points this function is analytic one. Okay. So for that we consider the function. So that function is f of z by z minus a. Consider the function f of z by z minus a. So this is analytic, which is analytic function, which is analytic at all points, at all points within C, within C, except at the point z is equal to a. With the point, okay, so I already told you that y is not analytic at z is equal to a. So if you take z is a, so then this becomes 0, the denominator becomes 0. So in that point, that function is not analytic one. Okay, so now by considering a as the center, okay, what we see here, so I just try to draw this C now. So this is the curve C. Okay, just imagine this is the closed contour C, and z is equal to a is any point here. So a is the point, z is equal to a. So by taking a, z is equal to a is the center, you try to draw a small circle. So it should be very small. So just imagine this is the circle with the a as the center. Okay, a as the center, and okay, it is its radius, and you take that radius is some r. Now you write the same words here with the point, with the point, with the point a has center, a has the center, and radius r is its radius. By considering r is the radius of the circle, okay, radius r, draw a small, draw a small circle, draw a small circle. You take that circle is C1, such that it should be lying completely entirely inside C. C ಒಳಗಡೆನೆ ಇರಬೇಕದು. Circle C1, take it as one, C1 lying entirely within C, lying entirely within C. Okay, let's here we can use the consequence of Cauchy's theorem. What that second consequence is that, so if C1 and C2 are two closed contours, C2 lies entirely inside C1. So in that region f of z is analytic, then integration of f of z over C1 is same as integration of f of z over C2. That same thing we can write here. Here f of z is analytic function at the point z is equal to a. So now this in this region, in this closed contour, okay, so z is equal to a is not present here, so it is outside this region. So ಈ region ಮಧ್ಯ ಹೊರಗಡೆ ಇದೆ z is equal to a ಅನ್ನೋದು. ಹಾಗಾದ್ರೆ so that means, so this region, so the f of z by z minus a is completely analytic at all the points. It is analytic at all the points. Okay, because z is equal to a is not, it is not including the point z is equal to a. This region not including the point z is equal to a. So the function f of z by z minus a is analytic. So you can use the Cauchy's theorem here, consequence of Cauchy's theorem. So we have by Cauchy's theorem, or you can write it as a second consequence. So we have by Cauchy's theorem here. So now you consider integration of f of z, by z minus a into dz over c is same as integration of f of z by z minus a into dz over c1. So for any point on C, what is that any point on C1? Okay, you see this is the circle C1. Is any point on C1? So what is the equation of circle C1? So you can write the equation of circle C1 is mod z minus a is equal to r. Mod z, because a is the center, r is the radius, so you can write it is mod z minus mod, you can write that is the mod z minus a is equal to r. And any point on C1 means, so that is the point z. So you can write it is z minus a is equal to r into e power I theta, or z is equal to a plus r into e power I theta. So any point on C1 can be written as z is equal to a into, any point on C1 is z is equal to a plus r into e power I theta. I give the reason here why we have to write like this. Okay, so and what about dz? Dz ಏನಾಯ್ತಿಲ್ಲಿ, which implies that dz is equal to, so its differentiation with respect to theta is a is a constant, r into differentiation of e power I theta is e power I theta into I d theta. If you substitute this here, so then it takes the form integration of f of z by z minus a into dz is equal to integration over c1 f of z, that is a plus r into e power I theta, divided by z minus a. You can write that z minus a is r into e power I theta, and dz can be written as r into e power I theta into I into d theta, right? So any confusions? Yes. Okay, simplifying this, simplification gives that integration of f of integration of f of z by z minus a into dz is equal to integration of, here you can cancel this r into e power I theta, r into e power I theta. So remaining is I into f of a plus r into e power I theta into d theta. As here we draw a circle. So we consider its radius is some arbitrary radius r. We can take the circle with we can draw a circle with center A and radius is r by 2. That means we can reduce the radius. We can shrink the circle. So I just we just take a circle. It should be as less radius as possible. Andre radius na kadime ಮಾಡ್ತಾ ಹೋದ್ರೆ it shrink to a point. Finally it shrink to a point. So point means that means its radius is goes on decreasing, not zero. Okay, zero ತಗೊಳಂಗಿಲ್ಲ. So but its radius should be goes on decreasing, because our intention is to exclude the point z is equal to a. ಯಾಕೆಂದ್ರೆ z is equal to a ನಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, so function f of z by z minus a analytic ಆಗಿರಲ್ಲ. Okay, so for that we need to take one small circle, so it should has very less radius, that is r tends to 0 to, so you take the limit as r tends to 0 on right hand side. So then what happens, so in the limiting so okay, in the limiting form you write the same. In the limiting form, so in the limiting form has the circle C shrinks to the point it shrinks to the point A, so that is as r tends to 0, the integral you take this is 1. Okay, so the integral 1 approaches to then you take r tends to 0. So then if you take r tends to 0 here, then what happens, integration of f of z by z minus a into dz over c, okay, which is equal to I into integration of f of a into d theta. And what about that limits? Here theta varies from 0 to, in circle theta varies from 0 to pi by 2, or 0 to 360 degree, that is 0 to 2 pi. So take theta, limits of theta is 0 to 2 pi, 0 to 2 pi. Okay, and you go on integrating this I into f of a. Integration with respect to theta is theta, limit 0 to 2 pi. Okay, apply the limit, that is which is equal to I into f of a. Apply the limit 2 pi minus 0, which is equal to 2 pi I into f of a. Integration of f of z by z minus a into dz over c is equal to 2 pi I into f of a, or you can write it is f of a is equal to 1 by 2 pi I into integration of f of z by z minus a into dz over c. Okay, this is Cauchy's integral formula. Cauchy's integral formula. Just need to, and once again, yes, we need to prove this formula. So for that we consider a function f of z by z minus a. So this function f of z by z minus a, if you consider this is a total single function, so then this is the function is analytic at all points except z is equal to a. So for that, by using z is equal to a as the center, you draw a circle with radius r. So you take that circle is C1. Okay. So by now in this region, in this closed contour, okay. So in this region, so that is the region between C1 and C2, E regionally, in between the region between C1 C2, f of z by z minus a is analytic function. If it is analytic function, we can use the Cauchy's theorem, consequence of Cauchy's theorem. So by using the second consequence of Cauchy's theorem, second consequence in so if this is the region, in this region, C1 and C2 are two closed curves. Okay, C1 and C2 are two closed curves. C2 is lies entirely inside C1. So then integration of f of z over C1 is equal to integration of f of z over C2 ಅಂತ ಹೇಳಿದೆ. So we are using the same consequence but here the function is f of z by z minus a. F of z by z minus a is the analytic in between C1 and C2 curves. Okay, so integration of f of z by z minus a over C1 C is equal to integration of f of z by z minus a over C1. So here C1 is the circle, mod z minus a is equal to r. So you can write z minus a is equal to r into e power I theta, or z is a plus r into e power I theta. Any point on the circle is like this, z is equal to a plus r into e power I theta. You differentiate this, and if I substitute the values of dz here and substitute the value of z here, and z minus a is r into e power I theta, you substitute all that and take the limits for theta. Theta varies from 0 to 2 pi, and substituting this, and we consider a circle with radius r. Okay, we can consider a circle with r by 2 also. So that means you go on decrease the radius. So because here we are not particularly mention the radius of the circle C1. Okay, it should be as small as possible. So that means r should tends to 0. The radius should tends to 0. If we take the limiting point of r is r tends to 0. So in this integral, so then what happens? So it becomes r becomes 0. Remaining is f of a only here. F of a into d theta. For that, to that you apply the integration. You get the integration is theta from 0 to 2 pi. Apply the integration limit. So finally we have this one. Integration of f of z by z minus a into dz over c is equal to 2 pi a into f of a. Okay. What Cauchy's integral theorem says, if f of z is analytic function inside the closed contour C, so then integration of f of z dz is equal to 0. So if f of z is analytic function and f of z by z minus a is the another function, f of z by z minus a, f of z is analytic, and f of z by z minus a, in this one a is a point lies completely inside the closed contour C. Then integration of f of z by z minus a into dz is equal to 2 pi a into f of a. This is the Cauchy's integral formula. So I think you understand this concept, Cauchy's integral formula. So next I would like to discuss. So before going to problems, first you take a note on this Cauchy's integral formula. So that is as you differentiate both sides of equation 2 with respect to a. So differentiation of f of a is f dash of a is equal to 1 by 2 pi I into integration of, you can write it is f dash of f of z. Okay, because it is not consists of any a, so ಇಲ್ಲಿ differentiate ಮಾಡ್ತಾ ಇರೋದು with respect to a. Here we are differentiating with respect to a, so this is f of z is like a constant, so this is the factor consists of a term, so differentiation of 1 by z is 1 by z minus a is, it is like this, differentiation of 1 by x minus a like this. Okay, it is 1 by z minus a, z minus a ನಲ್ಲಿ a ಇದೆ, so ಇದರಲ್ಲಿ ಡಿಫರೆನ್ಷಿಯೇಷನ್ ಮಾಡಿದ್ರೆ it is like 1 by x, differentiation of 1 by x is minus 1 by x square, so write minus 1 divided by x square, that is z minus a whole square, and again differentiation of z minus a is minus 1 into dz. Okay, its simplification gives that 1 by 2 pi I into integration of minus becomes plus f of z by z minus a, f of z by z minus a whole square into dz. So again, if you want to differentiate this again, differentiate with respect to a, differentiate with respect to a, so on both sides, so then it is f double dash of a is equal to 1 by 2 pi I is a constant, you write as it is, integration of f of z, you have to differentiate this term, so that is differentiation, when you are taking differentiation, that ordinary differential becomes inside the integral, we have to take it is a partial differentiation, del by del a of del by del a of, if take this one to numerator, it is z minus a to the power z minus a to the power minus 2, z minus a to the power minus 2 into dz. Okay, so if you differentiate this 1 by 2 pi I into integration of f of z, its differentiation is minus 2 into z minus a to the power minus 3, again differentiation of z minus a is minus 1 into dz, which is equal to, I need some more space. 1 by 2 pi I, you see this minus of minus becomes plus, you can write it is 2 by 2 pi I into integration of f of z by z minus a to the power minus 3, or it is plus 3 into dz. This is f double dash of a. Similarly, f triple dash of a is like this, which is equal to 2 into 3. So when you take this one to numerator and differentiating this one, so then we get 3 here, 2 into 3, so you can write it is, in this case you can write it is 2 factorial, 2 factorial into 3 becomes 3 factorial by 2 pi I into integration of f of z by z minus a to the power 4 into dz. Okay, in general, fn of a, that is fn of a is equal to, if it is 3 we have 3 factorial, if it is n we must have n factorial by 2 pi I into integration of f of z by z minus a, this number is one more than this one. Okay, this, if it is consider the third order of f of a, so then we have 4 here, second order 3 there, so like that, if we take nth order, it must be an n plus 1 into dz. So this is Cauchy's integral formula for derivatives. Cauchy's integral formula for derivatives. So take one example of this type. It is very simple example. So evaluate integration of z square minus z plus 1 by z minus 1 into dz, where c is the circle. So in first case mod z is equal to 1, in second case mod z is equal to 1 by 2. Okay, in both the case we have to discuss this problem. So let integral, you take it as I, let I is equal to so let I is equal to integration over c z square minus z plus 1 divided by z minus 1 into dz. In first case mod z is equal to mod z is equal to 1. So mod z is equal to 1 is a circle with radius 1. Okay, if you consider that circle here, okay, you take this circle, with center, origin and radius is 1. Okay, so you take that radius point is 1 here, radius of the circle is 1. So in this one, if you compare this with Cauchy's integral formula, Cauchy's integral formula ಜೊತೆ compare ಮಾಡಿದ್ರೆ ಇದನ್ನ, so this is Cauchy's integral formula. So integration of f of z by z minus a into dz. What is in place of f of z? F of z place ಅಲ್ಲಿ ಏನಿದೆ? So in place of f of z we have z square minus z plus 1. So here f of z is, you write here f of z is equal to, it is z square minus z plus 1. So this is clearly this is analytic. Clearly f of z is analytic in mod z is equal to 1. In circle mod z is equal to 1. It is complete. So this is this function is analytic in mod z is equal to 1. And you notice that point. So z minus a, what is in place of a? A andre enide? A andre 1 ide illi. Okay, and a is equal to 1. So a is equal to 1 is a point lies inside the circle. So not inside, we can take it is lies on circle, lies on C, lies on circle mod z is equal to 1. So therefore integral value I can be written as I is equal to what that Cauchy's integral formula says. If f of z is analytic and z is equal to a is a point lies inside the circle or lies on the circle, so then its integral value is equal to 2 pi I into f of, okay, f of a. So therefore take it is therefore by Cauchy's integral formula, therefore by Cauchy's integral formula, by Cauchy's integral formula, so that is integration of f of z by z minus a into dz over c is equal to 2 pi I into f of a. We have, by using the same integration of f of z by z minus a. So what is in place of a? In place of a we have 1. So z minus 1 into dz is equal to 2 pi I into f of a. So in place of a we have 1. It is f of 1, which is equal to 2 pi I into what is f of 1? What is f of z? By using f of z you find f of 1. So f of z is, so if you wanted to find f of 1, put z is equal to 1 here. So that is 1 square minus 1 plus 1. That is this value becomes 1, which is equal to 2 pi I. So clear. Similarly, in the second case, so second case, in case 2, mod z is 1 by 2. So in second case, so that mod z is 1 by 2. That is a circle with the center, origin and radius 1 by 2. So radius is 1 by 2. And suppose this is the point here. Here z minus 1 means, so that a is equal to 1 is a point lies outside circle. A circle in the ಹೊರಗಡೆ ಇದೆ. That means, so this, if you consider this function, okay, write this. In this case, a is equal to 1 lies outside the circle. Outside the circle, mod z is equal to 1 by 2. It lies outside the circle, mod z is equal to 1 by 2. So what? So this function z square minus z plus 1 divided by z minus 1. So this is the function is analytic. So this complete function is analytic. Okay. So is analytic within C or within mod z is equal to 1 by 2. So in first case what happened is, first case so at z is equal to or a is equal to 1 is a point lies inside the region. Okay, function is analytic except at z is equal to 1, but that is the point lies inside the region, inside or on the region, that is the point on the region. So inside the region or on the region, this point a lies inside or on the region, Okay, in that case you use Cauchy's integral formula. Suppose this is the point outside the region, in that time you use Cauchy's integral theorem, because ಇದು ಕಂಪ್ಲೀಟ್ ಫಂಕ್ಷನ್ ಅಂತ, ಇದು ಅಷ್ಟನ್ನು ಒಂದೇ ಫಂಕ್ಷನ್ ಅಂತ ತಗೊಂಡ್ರೆ ನಾವು, ಇಫ್ ಯು ಕನ್ಸಿಡರ್ ದಿಸ್ whole thing as a single function, z square minus z plus 1 by z minus 1 is f of z, you take this is f of z, so then this function, this complete function f of z is analytic inside the circle, because where it is not analytic, at z is equal to 1 it is not analytic, that is the point lies outside the circle, ಅದು ಹೊರಗಡೆ ಇದೆ ಅಂತಂದ್ರೆ, ಇಫ್ ಯು ಟೇಕ್ ದಿಸ್ ಇಸ್ ಅ ಸಿಂಗಲ್ ಫಂಕ್ಷನ್, ಇದು ಅಷ್ಟನ್ನು ಒಂದೇ ಫಂಕ್ಷನ್ ಅಂತ ತಗೊಂಡ್ರೆ, ಸೊ ಇಷ್ಟು ಕಂಪ್ಲೀಟ್ ಫಂಕ್ಷನ್ ಏನಾಗಿರುತ್ತೆ, ರೀಜನ್ ಅಲ್ಲಿ ಅನಾಲಿಟಿಕ್ ಆಗಿರುತ್ತೆ. ಸೊ ಅಕಾರ್ಡಿಂಗ್ ಟು Cauchy's ಇಂಟಗ್ರಲ್ ಥಿಯರಮ್, Cauchy's ಇಂಟಗ್ರಲ್ ಥಿಯರಮ್ ಏನ್ ಹೇಳುತ್ತೆ ಅಂದ್ರೆ, ಸೊ ದಿಸ್ z is equal to a is the point that lies outside that region, so then you treat this complete function is f of z, and integration of f of z over c is equal to 0 anta helutte. What it says? Cauchy's integral theorem. So here use the Cauchy's integral theorem. Therefore by Cauchy's theorem we have, therefore by Cauchy's theorem, so integration of z square minus z plus 1 divided by z minus 1 over c into dz is equal to 0 in the curve mod z is equal to 1 by 2. Suppose ನಿಮಗೆ ಇದರಲ್ಲಿ ಕನ್ಫ್ಯೂಷನ್ ಆದರೆ ಒಂದು ಕೆಲಸ ಮಾಡ್ಬೋದು, ಏನಂದ್ರೆ, so lies inside the region or lies on the region, in that time use the Cauchy's integral formula. Inside the region ಅಲ್ಲಿ z minus a ಪಾಯಿಂಟ್ ಇದೆಯಲ್ಲ, ಅದು ಇನ್ಸೈಡ್ ದ ರೀಜನ್ ಅಥವಾ ಆನ್ ದ ರೀಜನ್ ಇದ್ರೆ Cauchy's integral ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿ 2 pi I into f of a. Outside the region ಇದ್ರೆ use Cauchy's integral theorem, so and you write its answer is 0. Okay, so remember this point, this is very good example for this because in coming problems we see many of this type of cases. For that, if the point a lies inside the region, then you use Cauchy's integral formula. Lies outside the region, then you use Cauchy's integral theorem. According to Cauchy's integral theorem, its value is equal to 0. Okay. So, okay, thank you. I want to stop this session. So next coming sessions, I would like to discuss some more problems on Cauchy's integral. Okay, thank you.